Hi guys, how are you all? And today we're gonna discuss explanation of data flow diagram of ARM processor by Ganashiva and introduction to data flow diagram of ARM processor. Here, a data flow diagram of an ARM processor illustrates how data moves within the processor during the operation, how the data will forward inside the registers, how is the processor, and the process will occur. We are going to study in this uh, in this topic. It provides a clear visual representation of the flow of diagram from input to the output within the processor, and how the data will move from input to the output within the processor. We can found in this diagram. See, data is flowing, and instruction instruction decoder we are finding here, and here register are used to store the temporary data, and R0 here from R0 to R15 resistors we have here. R0 to R6 is the low resistors we have, and R8 to R12 those are high resistors, and we have R15 is nothing but the program counter. We have considered this, we named it is, we have given the name of R15 is a program counter. Here the DFT data flow diagram helps in understanding the internal working of ARM processor, and uh, aids in aids optimizing its performance. And here components of ARM processor data flow diagram, and which are the components we can found here. The DFT of data flow diagram of the ARM processor includes components such as, see, components register we need register to store the temporary data, and the ALU arithmetic logic unit, and here memory to store the data, and buses to communicate from one component to another component. The register store the temporary data. See, so the register store the temporary data during processing, and the ALU performs arithmetic and logical operations. This ALU arithmetic logical unit which will perform the arithmetic and logical operations. We know the logical operations already. Logical or and not, these are the logical operations. And memory stores the program instructions and data, and bus facilitate the transfer of data between components within the ARM processor. And your data flow in the ARM processor fetch stage. During the fetch stage, the uh, program counter PC PC is nothing but program counter points to the address of the next instruction in the memory for the further processor, and the instruction located at the memory address pointed by the PC is fetched and stored in the instruction register. Here register we know for the storing purpose. Temporarily to store the data we require the register particularly, and the fetched instruction is then decoded to determine the operation to be performed. Yes, see, we found the control unit. This was decoded, and see, arithmetic, whatever arithmetic logic unit is, the arithmetic and logical operations we are going to be done in there and executing. Then it will store in the RAM. RAM it can store, and then it will fetch to the control unit for the decoding purpose. Then the processor will be continuous. The data flow in the ARM processor decoded stage. In the decoded stage, the fetched instruction is decoded into identify the operation and operands, and the decoded instruction specifies the data processing operation to be performed by ALU. Only ALU will be operation will be performed. This is arithmetic, whatever the logical operation which are going to be done over there. Control signals are generated based on decoded instructions. Here control signals, which are control signals, are generated based on the decoded instructions. Whatever the decoded instructions will be there, based on that the control signals are going to be generated to coordinate the flow of diagram within the processor. And your data flow in the ARM processor execute stage. It is we are going to study the execute stage in this slide. And during the executive stage, the ALU performs the arithmetic or logical operations during the executive stage. ALU performs arithmetic or logical operations. Arithmetic, we know that plus, minus, division, more, multiplication, these are the arithmetic operations, and these are logical, we know the AND or NOT gate, and OR gate, which will be addition operation, and the AND gate is a multiple operation, and NOT gate, we all know if we give a false, it will comes true. The opposite performance will be going to be done in the NOT gate, and specify the decoded instructions, and the operands required for the operation are fetched from registers or memory and supplied to the we are temporarily register the data in registers and memory, we are fetching from there and supply to the ALU for the process, right? And the result of the operation is then stored in the destination registers or memory locations. And here summary of the data flow diagram of ARM processor. Let's come into the summary of data flow diagram of the ARM processor. The data flow diagram of an ARM processor illustrates the flow of data within the processor during the different stages of operation. Okay, and it helps in understanding how data moves between components such as registers, ALU, arithmetic logic unit, and memory to execute the instructions. It helps to understand how data moves between the components, and by visualizing the data flow, developer can optimize the performance of ARM processor for various applications. And this is the topic for this class, today's class. And thank you for the watching. Do like my video, and don't forget to like, only like I need, and it will fetch some marks to me. Thank you for the watching.